Hello again, welcome to another lesson in Algebra 1. Today we are covering section 6.7, graphing linear inequalities involving two variables. All right, so we have a warm-up on just graphing some lines to start with. All these lines are in slope-intercept form. Okay, so the first one, y equals mx plus b. So our slope is 2 over 1. And the y-intercept is positive 4. So we start by putting a point at positive 4, and then we will go up 2 and right 1 to get more points, or down 2 and left 1, because the slope, or the steepness of this line, is positive 2. All right, so we get y equals 2x plus 4. We write our label on the line. All right, so the second one is special case. This is in case you've forgotten that this is a vertical line, you can always make a little chart. X is 3, and Y can be anything you want. So this is 3, 0, 3, 1, 3, 2, and that's why this is a vertical line. Remember, the slope is undefined because it's too steep, and it does not have a y-intercept. Number 3. Once again, we can write it y equals mx plus b above it. And then it's easy to see that the steepness of the line, or the slope, is negative 2/3. And the y-intercept is negative 1. So we start at negative 1 on the y-axis. And then we go down 2 and right 3 to get new points. So down 2 and right 3, because that's the steepness of our line. So we got y equals negative 2/3 x minus 1. And then the last one is a horizontal line, but if you've forgotten that, you can always make the chart here. So 0, 2, 1, 2, 2, 2, 3, 2 are all points on here. So 0, 2, 1, 2, 2, 2, 3, 2. And then we can see why it's a horizontal line. That goes through 2 on the y-axis. So this one actually is in slope-intercept form. This is just 0x plus 2. So there's our slope, and there's our y-intercept. All right, on page 2, our directions say, tell whether each ordered pair is the solution to the inequality. So we want to test each ordered pair. The ordered pair in the first one is xy. Remember, it's an ordered pair because the x coordinate comes first. And we want to plug it in for the x and y and see if this statement, this mathematical statement, is true. So replace the x variable with 0. We replace the y variable with 0, and we're testing, is this less than 10? So we put a question mark over the less than. Now, 4 times 0 minus 2 times 0, that's just 0. And we look at what remains and we say, is that a true mathematical statement? So 0 is less than 10. This is true. So that means that 0, 0 works for this inequality. So 0, 0 is a solution. So yes, it's a solution. All right. Second one, we're testing 0, 0 again, which is nice because 0, 0 is a really easy point to test. So 0 is less than or equal to 2 times 0 minus 5, question mark. And in this case, let's see, we get 0 on the left side. 2 times 0 is 0, and 0 minus 5 is negative 5. So 0 is less than or equal to negative 5. Be careful here, there might be a typo on your worksheet, so that might say greater than or equal to, so please change it if it does. And since 0 is less than or equal to 5 is a false statement, 0 is not less than or equal to 5, then we should put not a solution. So 0, 0 does not work, okay? All right, and then in our last one, we're testing x, y again. So x is negative 1, y is 2. So we're going to plug in negative 1 for x, 2 for y. And we're testing on less than or equal to 5. So that's a question mark. So negative 1 minus 6, because this multiplies to 6, will make negative 7. And negative 7 is less than 5, so that works. Okay, so we say yes, it is a solution. All right. So 1 and 3 do work. Number 2 does not, but remember, be careful and check this and make sure that it says less than or equal to on yours. All right, so here are our steps for graphing linear inequalities, which is a lot like graphing linear equations. except we just have to figure out which way to shade. All right, so step one, graph the boundary line. The boundary line is the normal equation, the normal line we usually graph. Sometimes we're going to make this boundary line be dotted, and that's if there's no equal to bar. And sometimes we'll make it filled in, and that's if there is equal to bar, so a solid line. And it's the same reason why we graph in 1D space. Sometimes we fill in the circle, and sometimes we don't. Except now the boundary, instead of being a circle, is a whole line. All right? All right, step two, we're going to test a point not on the boundary line, so some other point. Just like we did when we used to graph these to begin with, we learned by testing some point until we figured out a pattern of how they go. All right, so we're going to test some place not on the boundary. We couldn't test the circles here. Okay, so the origin, 0, 0, is usually the easiest point to test, which is why up here we practice doing that in questions number 1 and 2, testing the origin. Okay. And then, of course, if the origin is a solution, we shade that half of the plane. If it's not a solution, then we don't shade that half of the plane. So let's do a problem here. All right, so first we're going to graph y equal to 2x plus 4. This is our boundary line. Okay, so I got a y-intercept of 4. 1, 2, 3, 4. Well, that looks familiar. And a slope of 2, so we'll go up 2 and over 1. And we put our line through here. Now, I did something wrong. And remember, what it said here was our boundary line would be solid if it was an equal to bar, but this one does not have an equal to bar, so we have to put a dotted line through there. So 1, 2, 3, 4. We go up 2 and over 1. And now we have this dotted line. Okay? So our boundary is like an open circle, except instead of a circle, the boundary is a line here. So we put a dotted line because there's no equal to bar. All right, now we're going to test a point. The easiest point to test is the origin, 0, 0. So we'll try to see if 0, 0 is on the shaded part, the half of the plane in our solutions. So I chose to test 0, 0 because it wasn't on the line and it's the easiest point to test. So I'll plug 0 in for y, question mark. I'll plug 0 in for x. And then we'll add up the left side or right side here. So we get 0, 2 times 0 is 0, plus 4 is 4. 0 is not greater than 4. So we are going to shade away from the test point, 0, 0. And that's because our test point was not a solution. If our test point had been true, then we would shade towards it. So that means all of the answers is everything on this half of the graph. So that's why it says shade half of the plane. These answers go on forever. Okay, there's millions and bazillions and trillions of them, an infinite number, but there's also an infinite number that don't work, all the ones on this half that aren't answers. So these are solutions, and the other side are not solutions. Okay. All right, so just to illustrate that point, I do want to pick one more point on this problem. So maybe we'll deal with negative 5, 0. Okay, if I test negative 5, 0, that's 0 for y and negative 5 for x. And then we get 0 greater than negative 10 plus 4 is negative 6. And that would be true. Okay, and that's why negative 5, 0 is a solution. Okay, on number 5 here, we are going to graph y is less than x plus 2. So the first thing we're going to do is graph our boundary line. So we'll graph y equals x plus 2. So we'll go to x plus 2 here. That's 2 on the y-axis, and then the slope is 1, so up 1 and over 1. And we're going to put a dotted line on our boundary line this time. And that's because instead of less than or equal, it has less than. Okay. All right, so we got to pick a test point, and the easiest test point, as always, is 0, 0. Okay, so we'll plug in 0, 0 and see if it makes this statement true. So is 0 less than 0 plus 2? This is a question mark. So 0 less than 2. This is yes. Okay, so we're going to shade towards 0, 0 this time. So shade towards 0, 0, because 0, 0 is a solution. Okay. So this worked. That was a solution. So since 0, 0 is one of our answers, all the shaded area will be on the same side as 0, 0. Okay. And our last one here, number 6, we want to graph the inequality y greater than or equal to 2. So first we'll graph the boundary line y equal to 2, and then we'll decide whether to make it dotted or solid. So y equal to 2 is a horizontal line, and this time it's going to be solid because even though it's greater, it's also equal to. So our boundary line is going to be solid here. And now we can test again, and I'm going to test once again 0, 0. It's always the easiest point to test, and as long as 0, 0 is not on our boundary line, we can use that point. If 0, 0 happens to be on the boundary line, then you have to pick any other point, okay, that's not on the boundary line. So I'll test 0, 0. I just plug in 0 for y, and I want to know, is 0 greater than or equal to 2? Okay, and this is no, 0 is not, so this doesn't work. So our test is no. All right, so we're not going to shade the side with 0, 0, so we're going to shade away from 0, 0. Okay, so this stuff up here. All right, so if 0, 0 would work, we would shade towards 0, 0. If 0, 0 doesn't work, then we shade away from 0, 0. All right, so your follow-up tonight is to complete the Khan Academy recommendation, graph inequalities and check solutions. And this will be due no later than the day after our next class. You really want to get started on it. And if you're struggling with the questions, then you want to go back and watch this video, or you want to go and watch the video that accompanies this lesson on Khan Academy. Something to help you learn better, okay? All right, I'll see you in class next time. And if you're still struggling, you want to schedule some time to get some help.